In this lecture, we are going to discuss some more properties of congruences. If you recall, in the previous video, we have defined how is A congruent to B modulo N. What is the definition of A congruence to B, A congruent to B modulo N? It is equivalent to say that N should divide A minus B, where A and B are integers, and this N should be a positive natural number. Okay, so N should be a natural number. Let me not write now positive. N is just a natural number. And now let us see some one or two important properties of congruences. So let me write one result here. So if A is congruent to B modulo N and C is congruent to D modulo N, then certainly I can say do something of these congruences. Like if you have, let me just discuss a small example here before writing the result here. So if I have 15 is congruent to 5 modulo 5 and 20 is congruent to 15, or let me say 20 is congruent to 10 modulo 5. Is this correct? Is this correct? Let's first check this. Okay, does 5 divides 15 minus 5? Does 5 divide 20 minus 10? We are going to ask this question. So does 5 divides 10? Yes. This is saying 5 divides 10. Is that correct? Yes. Does 5 divides 10? Yes. Because 10 can be written as 5 into something. So this means that 5 will divide the number 10. Okay. So here I have 15 congruent to 5, and here I have 20 congruent to 10 modulo 5. So this both these equations are actually both are correct. And now what we want to do, so I'm comparing it with this situation. I'm comparing with this situation. Okay, so in this case, can I add these two congruences? Can we just add them? So 15 plus 20 is 35 and 5 plus 10 is 15. So is 35 congruent to 15 modulo 5? Is that the correct answer? Is that correct? So I'm asking myself that does 5 divides 35 minus 15? Is this correct? Means does 5 divide 20? So yes, 20 can be written as 5 into something, that something is 4. So yes, so 5 does divide 20. So it means that this plainly tells me that you can add two congruences and still nothing will happen, right? Both the congruences must be with respect to the same natural number n. You will see that I have used the same natural number n for both the congruences, right? Then the result I'm trying to say is A plus C is always congruent to B plus D modulo n. Okay, and the solution of this is very easy. The justification of this is also very easy. So A is congruent to B. You know that A is congruent to B is given to us from this equation. A is congruent to B modulo n. This means that n divides A minus B. This is say 1, and C is also congruent to D modulo n. So by definition, again I can say that n is congruent to C minus D. This is the second thing. And if I combine 1 and 2, I can now see that n divides A minus B also, and n divides C minus D also. And therefore, by using the property of divisibility, I know that if A divides B and if A divides C, then I can say that this A must divide B plus C. So this means that n should divide A minus B plus C minus D, and which is nothing but if I rearrange the terms in these brackets, I'm going to say A plus C minus B plus D. So n divides A plus C minus B plus D. This means that A plus C and B plus D, both are congruent to each other modulo n. And this is what we actually were trying to prove, that you can add the two congruences, right? So if A is congruent to B and C is congruent to D, then I'm getting that when I add them, A plus C will be congruent to B plus D modulo n. So this is how you can simply add the two congruences. Okay, and now let us try to see if can I multiply the two congruences. Can I write AC and can I write BD? Are they congruent to each other modulo n? Now addition is clear, so in that case I can say that in the same way, if I subtract the two equations, I will get A minus C is congruent to B minus D. Okay, let me write it as a different result here. Let me not mix it in this statement. So A plus C is congruent to B plus D. I will say similarly, I can, instead of adding, I can subtract the two congruences. So A minus C will be congruent to B minus D modulo n. So even this result is also correct, right? Now let me multiply the two congruences. What is the result I'm trying to tell you? If A is congruent to B modulo n and C is congruent to D modulo n, then I must be able to show that A into C is congruent to B into D modulo n. Okay, so from the very first statement, I have that A congruent to B modulo n. This means that n divides A minus B. Okay, n divides A minus B, and we know that the definition of A divides B. What is the original definition of A divides B? You can write B is equal to AK. You can write B is equal to AK, where K is some integer. K is an integer, right? This is the original definition of A divides B. So what will be the definition of n divides A minus B? So A minus B is equal to n into K, but this K is some integer. This is the basic definition of A divides B. Okay, let me write K1 for some time, and later we will use another integer as K2. So this means that A minus B is nk1. I'm calling this equation 1. Okay, now let me write a definition of what is C divides D. Okay, I have C divides D also. So C divides D, sorry, C congruent to D, sorry, C congruent to D. So since we are given that C is congruent to D modulo n, so this means that n divides C minus D. So again, by the definition of divisibility, A divides B definition, I can say that C minus D must be n into some K2, where K2 is again some integer, and this equation I'm calling equation 2. Now we will try and go back to see what I actually want to prove. So I want to prove that AC is congruent to BD modulo n. Okay, so I will do something related to AC and BD. So what I will do is I will subtract AC and BD. Okay, so this is the crucial step of this particular proof. So I'll say consider AC minus BD. Okay, and I'm going to try and simplify this, or I'm going to add something. I'm going to expand it and do change this expression so that it will be convenient for me. So what we will do is we will add and subtract. We'll add and subtract AD in the above expression. So it means that AC minus AD and then plus AD. I'm just adjusting the AD and minus BC, the last term is as it is. So this AD plus and minus, I've just adjusted it, and the original AC and BD, I have kept them as it is. Okay, so this AC and this BD are kept as it is originally. I've not changed them anything. And then I will try to pair them up. So if I look at these two together, I can take A common, and I have C minus D, plus here I can pull out a D common, and I will have A minus B. Okay, so I have A into C minus D plus A minus B into D. Now if you recall what was your equation 1 and equation 2 above we have done. So equation 2 was saying C minus D can be replaced by what? NK2. So C minus D can be replaced by A into NK2, and A minus B can be replaced by what? It can be replaced by NK1 into D. Okay, this is equation 2, this is from equation 2, and this is from equation 1. A minus B is NK1, C minus D is NK2. What are K1 and K2? K1 and K2 are integers. And then I can pull out n common. If I just look at n common, it is A into K2 plus D into K1. So this ABCD are also integers. So this entire thing is some integer, and that integer I'm going to call K3, and this is n times K3. Who is K3? Let me write here, where K3 is also integer. What is that integer? It is AK2 plus DK1. So this is also an integer. So I started with what? I started with AC minus BD. Okay, started with AC minus BD, and I simplified it and showed that AC minus BD is n times K3. It means certainly n will divide AC minus BD, right? This is the definition of what A divides B. Let me again write it here. If you recall, A divides B means B is equal to AK, right? So this is B is equal to A into K. If this is like playing the part of B, this is playing the part of A, and this is playing the part of K. If B is equal to AK, then you can write what? A divides B. So A is here, A divides B. B is here. Okay. So this means N divides AC minus BD. Okay. So if N divides AC minus BD, this means which two people will become congruent to each other? AC will become congruent to BD modulo, and this is what exactly we wanted to prove, right? So what were we trying to prove? We were trying to prove that A congruent to B and C congruent to D, then I modulo n, both are modulo n, then I can simply multiply them, and I can write AC congruent to BD, and modulo n will be as it is. This is what the result we have proved above. This result is very important in solving problems. Okay, so with this, the topic of congruence and some important properties are covered. In the next video, we will discuss some problems on congruence.